Hello everyone. Now we are going to learn the group separation. The group separation present in our 6M inorganic practical under Calcutta University in the course of BSc Chemistry Honors. The group separation is very much useful for salt analysis of basic radicals, which are mainly cations. Now moving on to the next part, how these groups are appeared. These groups are completely different from periodic table group. Whereas in periodic table, elements are grouped on the basis of their respective electronic configuration, and here the basic radicals or the cations are grouped on the basis of their reactivity towards specific reagent and ease of formation of PPT present at that particular group reagent. Now, what is the group reagent? The group reagent are those particular combination of reagent on presence of which all the cation responses those are present on that particular group. Now moving on to the number of groups. Here is total 5 groups. The group 2 and group 3 has two subgroups called the 2A, 2B and 3A, 3B respectively. Now moving towards the group 1. The group 1 contains the lead cation, mercurous ion and the Ag plus ion. The group reagent for this group is 2 molar HCl. On the presence of the 2 molar HCl, the cation are precipitated in form of their chlorides. On the next part of the video, we can detect the specific chlorides. Moving towards the group 2, as we discussed earlier, the group 2 has the two subgroups, that is group 2A and group 2B. The group 2A contains the lead 2 plus, cadmium 2 plus, bismuth 3 plus and the copper 2 plus. Now the lead 2 plus is also present in the group 1 and is present in the group 2. This is due to the solubility issue of hot and cold condition. Now the group 3B contains the arsenic in +3 and +5 oxidation state, as well as the antimony and the T. The group reagent is 0.3 molar HCl in presence of the H2S gas. Now all the ions present in the group 2 along with the group 2A and group 2B are precipitated in form of their sulphides. Now moving towards the group 3. The group 3 also has the two subgroups, that is the group 3A and group 3B, and these are divided on the basis of their cation present in these particular groups. The group 3A contains the trivalent cation, that is Al3 plus, chromium 3 plus and Fe3 plus, whereas the group 3B contains the bivalent cations, that is the Mn2 plus, cobalt 2 plus, nickel 2 plus and the zinc 2 plus. Now these two groups has different group reagent. This group 3A, our group reagent is the solid NH4Cl and NH4OH, and we have to add the NH4H till the mediums become strongly ammoniacal or we get the smell of the ammonia, and all the ions are precipitated in form of their hydroxide, whereas the group reagent for group 3B is NH4Cl, NH4H and the H2S gas, and the cations precipitated in the form of their sulphides. Now moving to group 4. This group contains the calcium, barium and the strontium, and the group reagent is NH4 solid, NH4OH and the saturated solution of ammonium bicarbonate. And the ions are precipitated in the form of their carbonates. Now moving to the group 5, this group contains the sodium, potassium with magnesium and ammonium ion, and here is the no specific group reagent. This group also contains the lithium ion, but we didn't discuss it here and we could discuss it on the another separate video. Now moving the one of now discuss the famous question which is arrived from the group separation. The group 2 and group 3B, both the cations are forming the sulfide, although in case of group 3B we need NH4H, whereas in case of group 2 there is no need of basic media. Now this answer could be treated on the basis of the solubility product value of the sulfides. The solubility product value of group 3B sulfides are much higher than the group 2 sulfides. Now according to the solubility product value or the law of the solubility, we can concluded it that if the solubility product value is high, then we need the greater concentration of sulfide ion to precipitate that particular cation. So the solubility product values of group 3b sulfides are much higher. That's why in case of group 3b we need the greater concentration of the sulfide ions. And now moving to the next part of the answer. Therefore, to precipitate the group 3b sulfide, it requires the higher concentration of H2- compared to what is needed for the group 2 cations. For this reason, solution is alkaline in nature for the precipitation of group 3b sulfide, where the dissociation of H2S will be higher, but the group 2 cations require much less concentration of sulfide ions, which can be available the suppressed dissociation of H2S in the acid medium due to common ion effect. Now discuss the another question, why there is no specific reagent for group 5. As we already know that the group 5 contain the sodium and potassium salt, this since the all naturally occurring salts are water soluble, that's why there is no specific group reagent. That's for today's lesson. Thank you and keep learning.